Hi everyone, today we will examine 60 years of collected carbon dioxide data with you. Let's look at the tasks requested from us one by one. First of all, they are asked to read the data. With the read CSV function of the pandas library, we pull our data from internet and assign it to the df variable. And let's examine the data we have. As you can see, there are values such as year and month, as well as data on carbon dioxide. In our first question, we were asked to clean the data we obtained. As it can be seen, the year, month, day columns are separated from each other. We were asked to create a date column and combine them here. Also, the data you see in the days column is all -1. We are asked to change them to 1. Also specify the function we need to use as an extra. It makes our job easier. First, we assign the value 1 to days column of the df variable. Then, to create a new column, we open a new column named date in the df variable and write the toDateTime function in it. The thing we should pay attention to is that the datetime function takes one string type variable for days. So I am doing the multiplication operations to show the months, days, and years in df as a date type variable. Then I change the type of this variable with the apply str method. It asks us for the formats month, day, and year, but when we apply this format, we get an error. I still set the variables year first and day first to false to make them conform to this format. And now let's take a look at our df variable. We have a new column called date. Now we only want to have date, carbon dioxide, and trend columns. I am copying to a new variable called df2. The isin method you see here compares the values it contains with the values in the df variable and takes the ones that are not here. In this way, we get rid of unwanted columns. We are asked to index the date column and visualize the results. There are some anomalies in this figure in our attention. Between 1959 and 1980, the carbon dioxide line experienced deviation. The rest of the time, the trend and the carbon dioxide line increased and decreased at almost the same rate. Now we are asked to correct these unusual conditions. We need to use none instead of values with -99. But when we use none, we get an error in the interpolate function. Instead, I use the NumPy library's NotANumber method. Here I change the -99 data in the carbon dioxide column of the df2 variable to the np.none data with the replace method and make in place true to make it permanent. This way we see none data in our dataset. Now we are replacing our named none variables with the interpolate function requested from us. The interpolate method takes the entire data set and fills it by estimating the none values. Instead of none value in the fourth row of the carbon dioxide column that we just saw, it took the value 360. Let's see this changed by drawing. Now the anomalies between 1959 and 1980 have disappeared. Let's examine the data of 2008 and the years after in more detail. In the second question, we first ask the float value of the data in the date column. We create the date float column just like we create the date column and reach the year and month variables in the date column that we index in df2 and do our operations. Since there are 12 months in a year, I divide the integer month variable by 12 and add. We write the code of the operation whose mathematical formula is given. Then we optimize our curve using the optimize function of the SciPy library. But before optimizing, we are asked to predict which variable we should optimize using. For this, I first select the data for the x-axis and then add the output of mathematical function that is curve fun related to it to the y-axis. I am using the default range function to set a specific range. I collect the y-axis data with the y-noise variable to create a small curve on the y-axis. I draw this later. As you can see here, the data of the trend variable and the mathematical optimization process are very close to each other. Then I optimize it with the curve fit function from the optimize method, and the output of it is as it appears here. That's all I have now. Thanks for watching.